This is the last video for Chapter 8. Continuing with examples in Section 8.2, according to the National Center for Health Statistics, 15% of all Americans have hearing trouble, so that is your proportion, 0.15. In a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? So we're going to do a normal CDF here. In your homework, it's going to make you do these checks. It's going to make you at least do the one to make sure it's at least 10. You can usually assume this one's true, but you have to make sure it's normally distributed. And if it is, we can do a normal CDF using the mean and the standard deviation. So I'm just going to jump right into normal CDF. At most, 12% would be negative infinity to 0.12. with a mean of 0.15, and the standard deviation is the square root of 0.15 times 1 minus 0.15, sorry, that's a 1, over the sample size of 120. That's a 1. Okay. So that's kind of a large calculation, but your calculator can handle it. So we're going to do second bars, normal CDF, negative infinity to 0.12, 0.15 is our center, and the square root of 0.15 times 1 minus 0.15 divided by 120. So again, you can type that all in together. Just be careful where your commas and your parentheses are. With the older calculators, you're going to have a double set of parentheses at the end. With the newer calculators, if we do normal CDF, negative infinity to 0.12, centered at 0.15, and the square root of 0.15 times 1 minus 0.15 divided by 120. And I would close that parentheses just to make sure. So either way, you should get the same. Uh-oh, we did not get the same answer here. Let's see what happened. That looks right. Must have done something wrong on this one. Oh, I see what I did. So on the older calculators, on the older calculators, you have to close. I don't know if you can see it because it's on two lines. So it automatically opens that parenthesis, and then you open that parenthesis. You have to close the subtraction parenthesis before you divide by 120. There we go. So definitely have to be careful there on those older calculators. I'm going to clear this one out. So you should get 0.178, and that round round is 7. So 0.1787. One thing you can do, let me just show you. Typing this in, I know, is kind of a lot. So what you can do is type that in all by itself. Divided by 120. You can do the same thing on the older calculator, just the square root of 0.15 times 1 minus 0.15. Close that parenthesis before you divide. Get that number. And remember to use at least 4 decimal places, so 0.0326. So instead of typing this into normal CDF, you can type in the 4-digit rounded decimal, and it should give you close enough to the right answer. That's just one tip, because I know that's a lot to type in. All right, part B says, suppose that a random sample of 120 Americans who regularly listen to music, so it's a special type of sample, using headphones, so listening to music using headphones, results in 26 of them having hearing trouble. What might you conclude? So I want you to look at the difference between Part A and Part B. In Part A, they're giving us a percentage. Our proportion is a percentage. But in Part B, they're not giving us a percentage. They're just giving us an X value. So you have to be very careful on these problems. If it has a percentage, you're good to go. You just convert it to a decimal. If it just gives you a value, you have to do X over N. So I have to do 26 divided by 120 before I use normal CDF. And that is the most common mistake in this chapter that students just look right over. I know we always feel like we're in a hurry, and so we skip this step. But in the calculator, you have to enter a decimal because we're comparing it to a decimal. So we have to have like numbers to compare. So we're going to do normal CDF. Anytime your sample proportion is larger, or sample mean for that matter, is larger than your true proportion, you're always going to test the right tail. Anytime your sample proportion is less than your center, you're going to test the left tail. In statistics, we're always curious about what's going on in the tails. So if your sample is in the top, we worry about the top tail. If your sample's at the bottom, we worry about the bottom tail. So because our sample proportion is larger than our center, we're going to worry about the top tail. So we're going to go from 0.2167 to infinity. Centered at 0.15. And again, if you want to use that rounded standard deviation 0.0326, that might be a little bit easier to type in. And you'll still get the same answer. The most important part here, I'm going to emphasize it one more time, is that the number you put in normal CDF has to be a decimal because we're comparing it against a decimal. So those have to be like values.